Exploring a new Web API project. Now that we've created a new web-hosted ASP.NET Web API project, we'll explore some of the key elements created by the project template, which we will customize in order to create our own web APIs. We will focus on two key files: web API config.cs and values controller.cs. Figure 3 to 4. Figure 3 to 4. W. Evolvable config.cs and values controller.cs within the Visual Studio 2013 Solution Explorer Web API config. This C or Visual Basic.NET file is located in the App Start top level folder and declares the class Web API config. T. His class contains a single method called register and is called by code in the application start method inside of global.ajax. A. As its name indicates, the purpose of the class is to register various aspects of Web API's configuration. B. Y default, the primary configuration code generated by the project template registers a default Web API route. This route is used to map inbound HTTP requests onto controller classes as well as parse out data elements that may be sent as a part of the URL and make those available to other classes in the processing pipeline. The default Web API config class is shown in example 3 to 1. Example 3 to 1. D. Default Web API config class public static class Web API config. Public static void register HTTP configuration config. / Web API configuration and services. / Web API routes config.map HTTP attribute routes. config.routes.map HTTP route. Name default API, root template API / controller / ID, defaults new ID equals root parameter dot optional. If you are familiar with MVC development, then you may have observed that ASP.NET Web API provides a different set of extension methods to register its routes than the default MVC routes. F. For example, the very same new project containing the Web API config class also contains the following: public class root config, public static void register routes root collection routes, routes.ignore root resource.axt / path info, routes.map route. Name default URL controller / action / ID, defaults new controller equals home, action equals index, ID equals URL parameter dot optional. Having two root configuration methods can be confusing on first inspection, so it's worth explaining the high-level differences between them. T. Key point to keep in mind here is that these map methods are simply extension methods that create an instance of a route and add it to the route collection associated with the host. T. Key difference between them, and the subsequent reason behind the two different methods, is in the fact that ASP.NET MVC and ASP.NET Web API use completely different route classes and even route collection types. The details of these types will be discussed in greater detail in Chapter 11. But the reason for breaking away from the routing types used by ASP.NET MVC was to enable ASP.NET Web API to split from much of the legacy that resided alongside the route and route collection classes in the system.WebAssembly, thereby providing a great deal more flexibility in terms of hosting options. An immediate benefit of this design decision is ASP.NET Web API's self-host capability. Configuring ASP.NET Web API routing requires declaring and adding HTTP route in stances to the root collection. Even though HTTP root instances are created with a different extension method than that used for ASP.NET MVC, the semantics are nearly identical, including elements such as root name, root template, parameter defaults, and even root constraints. As you can see in example 3-1, the project template's root configuration code sets up a default API root that includes a URI prefix of API fol, load by the controller name and an optional ID parameter, W. Without any modification, this root declaration is typically sufficient for getting started creating APIs that allow for fetching, updating, and deleting data. This is possible because of the way in which ASP.NET Web API's controller class maps HTTP methods onto controller action methods. I'll cover HTTP method mapping in more detail later in this chapter, as well as in much greater detail in chapter 12. Values controller. The API controller class, which is the parent class of values controller, is at the heart of ASP.NET Web API. How we can create a valid ASP.NET Web API controller by simply implementing the various members of the IT controller interface in practice. We'll create most ASP.NET Web API controllers by deriving from the API controller class. This class plays the role of coordinating with various other classes in the ASP.NET Web API object model to perform a few key tasks in processing an HTTP request. Select and run an action method on the controller class. Convert elements of an HTTP request message into parameters on a controller action method and convert the return value of an action method into a valid HTTP response body. Run various types of filters that have been configured for the action method, the controller, or globally. Expose appropriate context state to the action methods of the controller class. By deriving from API controller and taking advantage of the key processing tasks that it performs, the values controller class that is included as a part of the Web API item. Plate shows the high-level abstraction that can be built on top of API controller. Example 3-2 shows the values controller code. Example 3-2. Default values controller class public class values controller API controller // get API / values public enumerable get return uString value 1 value 2 / get API / values / 5 public string get int ID return value / post API / values public void post from body string value / put API / values / 5 public void put int ID from body string value / delete API / values / 5 public void delete int ID. The values controller class, while simple, provides a helpful first look at the controller programming model. First, notice the names of the controller's action methods. By default, ASP.NET Web API follows the convention of selecting an action method, in part, by comparing the HTTP method to the action name. Or precisely, API controller looks for a controller action method whose name starts with the appropriate HTTP method. Therefore, in example 3-2, an HTTP GET request to /API / values will be served by the parameterless GET method. eFramework offers different ways to tailor this default name matching logic and provides extensibility points, enabling you to replace it entirely if desired. Read details on controller and action selection can be found in Chapter 12. In addition to selecting an action method based on the HTTP method, ASP.NET Web API can select the action based on additional elements of the request, such as query string parameters. Importantly, the framework supports binding these request elements to parameters of the action method. By default, the framework uses a combination of approaches to accomplish parameter binding, and the algorithm supports both simple and complex .NET types. For HTTP responses, the ASP.NET Web API programming model enables action methods to return .NET types, and it converts those values into the appropriate HTTP response message body using content negotiation. You can find much more detail on parameter binding and content negotiation in Chapter 13. At this point, we've discussed some of ASP.NET Web API's design, and we've scratched the surface of the programming model in looking at the code provided as a part of the project template. We'll now go a bit deeper and create our first Hello World Web API. Hello Web API.